Hi, everyone, and welcome to Progress Support with our ISAC awardees. Today we have Dr. Clyde Campbell joining us, and we're going to go ahead and get started in the conversation. Dr. Campbell, if you can just start by telling us the institution that you're connected to, what your project was that won you the ISAC award, and just we'll go ahead and start with that.
Lead stated, my name is Clyde Campbell, and I'm an assistant professor at Iowa State University. My ISAC proposal was centered around this concept of integrating inflammatory dynamics into the in vitro production of hematopoietic stem cells in order to optimize and basically increase output of these valuable cell types.
What are the most significant milestones you've achieved in your project thus far? And just what are some things that you're super proud of that you've been able to do since winning? Any published publications that you've been able to have in just, peer review um, materials, just anything that you would like to highlight since winning the Isaac Award that you would like to share?
Mhm. Well, the ISAC has been super exciting for my laboratory in general. So my laboratory mainly utilizes zebrafish model organisms to to understand how blood cells are made naturally. And so a lot of my time in science is centered around using this model organism, which has a lot of great advantages to it. They develop externally and they develop extremely rapidly. And so a lot of these findings we identify using the zebrafish model. We like to integrate into human systems. And one of the most exciting things about receiving the ISAC award is that it gave us the foundation and the support necessary to really integrate some of our most exciting findings directly into the human system, which would not have been possible using more traditional routes of funding. So it was very exciting for us.
Amazing. And I'm sorry, I don't know if you mentioned, have you published yet?
Right now, the project is still currently ongoing. We're
Okay.
working with a collaborator of ours, Julia Pavani, at the
Hmm.
Children's Hospital of Philadelphia, to do our engraftment assays. So we really had a good idea and understanding of the quantity of HSCs, blood stem cells that we were generating. Now we really want to identify and interrogate the quality of these cells. So we're going to work in collaboration with, again, the Children's Hospital of Philadelphia to assess their engraftment potential and just how well long-term lineage potential these cells have. So we are currently in the process of putting together a manuscript. And a lot of this work is done driven by a phenomenal graduate student of mine here in the laboratory, Prince Ameo, who was really integral in getting all of this together. But the findings are extremely exciting to us. We're really recapitulating all of our in vivo findings into the in vitro system. So everything so far has been really exciting, and I think it's really going to help push the field closer to ultimately making, the use of lab derived blood stem cells for transplantation a reality in the future. So that's extremely exciting.
Oh, nice. Thank you so much for sharing all of that. And you actually answered one of my questions because I was wondering how had winning the award and being able to, have this be funded, did it, attract new collaborators and, partnerships and things of that nature. So it's good to hear that you guys are working with the Children's Hospital of Philadelphia. So congratulations on that. And congratulations to your grad student as well. Another question that I had was how long were you working on the project prior to applying and winning the Isaac Award?
Okay, so the project has been ongoing for really the real root of this whole project stems from discovery with one of my collaborators and colleagues, Dr. Raquel Espin-Palazon, who in 2014 really identified that inflammatory signals, which when you hear them, you think, this is a bad thing, a negative thing. It's due to infection, inflammation. But these signals are extremely important to pattern the development of the embryo. So ever since 2014, in that publication in Cell, our labs have been focusing on how inflammatory signals drive development. So this project has been ongoing since then, and it really opened up this entire new field. The ISAC award in general is patterned around a recent publication that my lab did in 2024, which was a Nature Communications publication, just showing how the inflammatory dynamics during embryogenesis is temporally regulated and the function that it's actually providing during this development. So it's a key regulator of determining cell cycle, whether the cells are quiescent or proliferative, as well as the delamination, so the attachment to the stroma. So it feels like I've been working on this project forever, but it really stems from a recent publication in 2024. And one of the things we've always wanted to do is to take those findings and translate them into human systems. Being an assistant professor, funds are limited, and in vitro studies are extremely expensive. Cytokines, just the labor-intensive aspect of in vitro work made it really not possible. So it was like these amazing developmental findings we did, but like there was no way to bridge that gap into bringing it into reality or translation into human systems. So the fact that we got the award really set us up to do something that we always wanted to do. And probably the most validating thing is to see and recapitulate everything we saw in vivo in this in vitro system and identify and visually see the potential that it has moving forward towards the generation of new cell replacement therapy. So all that was super exciting, and it would not have been possible without the support from the ISAC Foundation, or proposals, I should say.
Well, we're so glad that you applied. We're so glad that you stepped out and put your project on in the application pool, and then glad that you won. So just congratulations on all of that. Another question that I had, because I'm always interested in learning the people behind the data, did you have any specific personal connection outside of, like, I know you mentioned kind of this being introduced to you back in 2014 and working on it for this long amount of time. Outside of that, did you have any personal connection to the work, any personal connection to this particular project?
I do, in a sense, not a personal connection. My connection comes from visiting like children's hospitals or experiencing patients that are undergoing or living a life with blood cancers. So blood cancers are extremely prevalent in children, unfortunately. It's one of the highest cancers that exist in pediatrics. And so it's very difficult to observe that. So it really does kind of fuel a passion to help drive the development of potential new therapies, which is definitely needed in the field. And with the development of this idea of iPS cells, induced pluripotent stem cells, we now have the potential to take cells from a patient and turn them into hematic blood cells and give the patients back their own blood cells. The one thing that's really interesting about blood stem cells is that you only make them once during really early embryogenesis. So really before the mom even knows she's pregnant, the fetus has already generated all the blood stem cells they're going to need to sustain them throughout the rest of their life. And when you think about our body replenishes or needs to produce 4 million new blood cells every second, they all are derived from that very valuable population of cells during early development. And so what happens now when you're exposed to a blood cancer, treatments like chemotherapy are used, which are very aggressive, and they really deplete all the blood cells and all the stem cells in the patient. So they usually require after chemotherapy, they'll require transplantation. And the odds of finding a donor are extremely low. If you have a sibling, maybe it's 25%. If it's not a sibling, maybe 1 in 1,000 people is a match. And now if you're lucky enough to find a match, there's still a chance that those blood cells that are transplanted into the patient start to attack that individual. because these cells recognize the patient has a foreign, and so they have to deal with immunosuppressive therapies really for the rest of their life. So to now be able to kind of generate patient-derived blood stem cells and give them back their own cells, it alleviates all of those challenges for these patients, and has the potential to give them back a fully normal kind of quality of life following the disease, which is really exciting.
That's exactly why I asked that question, because again, like the impact that this research will ultimately have on our future, speaking of children, I think is just incredible. So thank you for sharing all of that. My final question for today is, if you could go back and tell young Dr. Clyde Campbell, and I'm not sure if you were a doctor at the time, but if you could go back and tell your younger self when you started in your research journey, if you could give yourself some advice, what advice would you give yourself?
Oh, that's a very good question. Um, I think I think the best advice is that criticism isn't negative, rejection isn't negative. You use them as fuel to kind of make your research stronger, make your proposal stronger, and to learn and grow from. Science is filled with challenges and a lot of things that work and a lot of things that don't work. And so, you could kind of beat yourself up over it uh, pretty easily. And funding is extremely difficult to get. So there's a lot of rejection that comes, and it's not necessarily indicative of the type of science you do, but sometimes, it just, everything doesn't align for certain projects to get funded. So, very early on, that was probably one of the bigger challenges. So, I would refocus that energy of disappointment into fuel to grow from. And now I love criticism. So I love to share my proposals with my colleagues and my manuscripts. And I love it when they have very constructive feedback that pushes the science further, because in the end, that's what stands up is strong science. And the way you make it stronger is to get new inputs and look at new viewpoints of your science and try to integrate it to strengthen it. So that would probably be my number one thing.
I think that's incredible advice, and I think that anybody can take that advice in their every industry, to be honest,
Mm.
because we all come with different criticisms and things of that nature. But I think that was just spot on. So thank you so much, Dr. Campbell, for this conversation. I think it was such great insight into where you are in the project and all that you guys have been able to do, and even the impact that it is going to have in the near future. So thank you so much, and that concludes Progress Report with Dr. Clyde Campbell.